Concept number 3 is all about solving systems by our third method, which is elimination. And our objective is I can solve a system of linear equations, again I'm going to abbreviate, in two variables by elimination. So this is the third method we're learning. We've learned about graphing, substitution, and now we're going to learn about elimination. We're actually going to spend 2 days on elimination because there are 2 types of elimination. So in this first little bit of a video, I'm going to teach you the one way, and then in the next one we're going to learn the second way. Okay, so elimination method is a method for solving systems of equations by adding or subtracting to eliminate a variable. That's where the word elimination comes in. You want to eliminate a variable. Okay, so elimination method is adding or subtracting to eliminate a variable, basically. Okay, so here are our steps to use elimination method, steps to solve. Step number 1, make sure the equations are lined up. You want all the variables to be lined up. So you want them in the same form, so same form, whether that be slope-intercept form, standard form, either of those would work. They both have to be in the same form. Okay, step number 2, add or subtract the equations to eliminate the variable with common coefficients. Okay, that's your goal. You want to make opposites, really. You want common coefficients, but you want one plus and one minus. And I'll show you what that means when we start solving these. Okay. Step number 3, solve for the remaining variable. Because one of them is going to go away, there's going to be one left. And then step number 4, substitute your answer into the other equation and solve for the other variable. Okay, so that's how elimination works. So let's do some examples. I'll do the odds, and then in class we'll do the evens, just like we usually do. Okay, so number 1, make sure the equations are lined up. Look, these are both in slope-intercept form, which is what we want. The y's are lined up, the x's are lined up, and the constants are lined up. So now we can just simply add or subtract to get variables by itself. Okay, so I want to look for common coefficients. Well, these both have a 1. This has a 3, this has a 1, and then we don't even care about the constants. So the variables I'm going to get rid of are the ones with the common coefficients, which are the y's here. Since these are both positive 1, I'm going to subtract the second equation because 1 minus 1 is 0, and I want 0. I'm not going to add these. I'm going to subtract because I want to eliminate the y's. So I'm going to subtract this whole equation. Okay, so I'm going to put minus and then put the whole equation in parentheses. So 1y minus 1y is 0. Equal sign's still there. 3x minus 1x is 2x. 4 minus a negative 2 is a positive 6, because minus a negative makes it a positive. Okay? So now what I'm going to do is I want to get x by itself. So I'm going to subtract 6 and then divide by 2. And x equals negative 3. Okay? I'm going to plug this back in to one of these equations up here so I know I can get what y equals. This one looks easier. So we're going to go y equals x, so negative 3 minus 2. Okay, well negative 3 minus 2 is negative 5. So we have our solution here. X is -3, Y is -5. We want to write it as a coordinate. There it is. All right. Let's do another one so we make sure we've got this. Number 3. These are both in standard form. That's awesome. That's good. We don't have to rearrange anything. So I lined them up. Okay. My common coefficients here, 3x and 3x, those are the ones I'm going to get rid of. So since they're both the same sign, they're both positive, I'm going to subtract this whole equation. Okay? So 3x minus 3x is 0. Negative 10y minus a negative 9y. Well, minus a negative makes it a positive. So negative 10y plus 9y is just negative y equals 14 minus 15 is negative 1. So basically the 0 is not there. I want to get positive y by itself, so I'm going to divide both sides by negative 1. So y equals 1. That was pretty easy. I'm going to take this and plug it into any equation I want. The bottom one looks friendlier, so let's do that. 3x minus 9 times 1 equals 15. 3x minus 9 equals 15. I'm going to add 9, so 3x equals 15 plus 9 is 24. Divide by 3, x equals 8. Okay, so my solution is 8, 1, because x equals 8 and y equals 1. All right? Okay, let's go to the other side and do number 5. Way up here. Look, my equations are all lined up. X's with x's, y's with y's. That's nice. So this time, I'm looking for common coefficients that are opposite, which is really cool. That's what you want all the time, really. But this is really neat. We have 4 and negative 4. I don't have to subtract. I simply have to add these two equations together, because if I add 4 plus negative 4, that's the same thing as 4 minus 4, so that's 0. They go away. Everything else I can just add together, which makes it really, really easy. So 4x plus negative 4x is just 0. 9y plus 7y is 16y. And then 5 plus 11 is 16. So y, if I divide both sides by 16, y is 1. That's really nice and easy. So let's plug it into one of the equations. Let's do the top one. 4x plus 9 times 1 equals 5. So I just replaced y with 1 since I know that's what it equals. I'm going to subtract 9 because 9 times 1 is 9. 5 minus 9 is negative 4. Divide by 4. X equals negative 1. So our solution for number 5 is negative 1. 1 because x equals negative 1 and y equals 1. Okay. Let's do another one. Number 7. So let's look and see. X has a 1 in front of it. Y has a negative 1. This one has a positive 1. These are opposites, so I'm going to add them together. Okay, so just keep following with me. X plus 3x is 4x. Negative 1y plus 1y is 0. Equals 10 plus 18 is 28. This isn't really there, it's just 0, so we can get rid of it. So to get x by itself, I need to divide by 4. And 28 divided by 4 is 7. Notice I'm not using a calculator for any of this stuff. You don't need a calculator to do this. Okay? We should know our multiplication facts, so we are going to stop using calculators. Okay? We are smarter than that. So I take this and I plug it in. I'm going to plug it into, I guess, I like the second one better. 3 times 7 plus y equals 18. This way you don't have to deal with negatives. So 3 times 7 is 21 plus y is 18. Subtract 21. 18 minus 21 is negative 3. So my solution is 7, negative 3, because x equals 7 and y equals negative 3. All right. Let's do another pink one. So we got 2 more. Number 9. Uh-oh, my equations aren't lined up very nice. So I need to get, looks like I need to get y by itself on this bottom one. So let's rewrite the whole thing over here. Let's write the top one, 4y equals 2x minus 8. Okay. So let's get 4y by itself. It doesn't matter if it's positive or negative. We actually want it to be negative to be the opposite of this. So we want to subtract 5x from both sides. So this equation here actually turns into negative 4y equals, let's line up our x's, negative 5x plus 20. Now they're all lined up. And since I have opposites right here, I'm just going to add these two equations together. Okay. So 4y plus negative 4y is 0. 2x plus negative 5x is negative 3x. Negative 8 plus 20 is 12. And now I just have to solve. So let's move 3x over. So 3x equals 12. What does x equal if I divide both sides by 3? X equals 4. So now I can take this and plug it back in. I'm going to plug it into this one right here, this top one. So 4y equals 2 times 4 minus 8. So 4y, 2 times 4 is 8 minus 8. Well, 8 minus 8 is 0. If I divide by 4, 0 divided by 4 is still 0. 0 divided by anything is 0. So y equals 0. So our solution to this whole thing right here is 4, 0. Okay? We have one more to do. Okay. This time our x and y's aren't lined up anymore, again, like this one, so I need to rearrange them. I think the bottom one is fine. I think on the top one we can solve for y pretty easily. So let's do that. So let's rewrite this one over here. Negative y equals 2x plus 10. If I get y by itself here, I just have to subtract 2x. So that goes away over here. So this is just now y equals negative 2x minus 10. Okay. So now all our y's are lined up, our x's are lined up, our constants are lined up. Now let's start solving. Well, look at this one, negative y and y, those are opposites, so I just have to add this whole equation together. So negative y plus y is 0. 2x plus negative 2x is 0. And then 10 plus negative 10 is 0. Interesting. 0 plus 0, or 0 equals 0 plus 0. When I have the same number on both sides and it equals each other, do you remember how many solutions that has? It has infinitely many solutions. So number 11 has infinitely many solutions because these two lines are the same. If you notice, this line here has all the opposite signs as this one. So this line just got multiplied by a negative 1. So they're ultimately the same line. Okay. All right, so that's it for this first part of concept 3. We're gonna do the next part of concept 3 on a different day so we can nail down this part, and then the next part we'll nail down another day.